So simultaneous equations, a bit of a blast from the past, hopefully you remember it. What I'm going to do is I'm going to show you one way of solving these. So I was just nervous there'd be some people who couldn't remember how to solve simultaneous equations. There's lots of ways to solve these, and most of them are more elegant and tidier than what I'm going to do here. But just in terms of using a method that always works when you've got two simultaneous or two equations with two unknowns, I'm going to show you that method of doing it. You may know other methods and you can use them if you know them. Alternatively, you can go and look at Mathematics for Engineers. I think it's chapter 7, block 4 is on simultaneous equations, and you can learn a whole heap of tricks for doing these more quickly and more easily. If your graphic calculator has an option for solving simultaneous equations, you could also use that. If you don't, we'll run through a method of doing that now. So first things first, what are they? So you remember if you were just doing an equation, you might have something like, I don't know, it could be 2x squared plus 3x minus, excuse me, try and write properly, plus 3x minus 4 equals 152 or something. So what you had is you had one equation and you also had one unknown. So in this case, we just had x is the only thing we don't know. If you've got one equation, you can find one unknown. What we're getting into here is now we've got two equations and we've got two unknowns. Because we've got two equations, we can solve that. If we had two equations with three unknowns, we wouldn't be able to solve it. So you need the same number of unknowns as you have equations. So if you were working with three unknowns, you would need something like this one here. And so you might have A, B, and C are your unknowns. Then you would need three equations to figure out what all of those were. And the method for solving them will get a little bit more complicated. Now, we're working here, the first few examples we're working with X and Y, so quite simple. It's how it would be when you were doing mathematics. What we'll find is when we're going to the engineering equations, it starts to get a fair bit messier. So it'll look something like this equation here. And you'll have lots of scruffy numbers with decimal places, and you might have more complex variables, fx, fy, or that sort of thing. But the same principles will apply, and we'll work our way up. The last example will be an example that I've taken from the tutorial, actually. So there's a bit of a cheat for you. We'll work through one of the tutorial answers here. So what do we do? Well, let's just write these out first. So let's just start off 4x minus 3y equals 0. We're going to call that equation 1. When you type these, you often do brackets. When you're writing, you'll often just do the number with a circle around it. And then we've got another equation, 10y plus 2x equals 20. What I'm going to do, we don't really need to for the method we're about to use, but for other methods that you might remember, it's tidier just to keep the letters in the same order. So if you've got x and y in the first equation, probably tidier to keep that order in the second equation. So it's going to be 2x plus 10y equals, correct, 2x plus 10y equals 20. I'm just going to tidy this up as well so they're all lines up, make it nice and tidy. We'll call this one 2, equation 2. Now, just when you're working with equations, a few other things you need to watch for. So first thing is you might be given it in the form, something like, so that could have been given to in the form 10y plus 2x, and it might have been minus 20 plus 10y plus 2x equals 0. And usually it's tidier to write them. So first you sort out the order. So you'd want to swap these around. And then you'd want to take this to the other side by adding 20 to both sides. And try and just get the letters in the right order. Plus 10y, and have your number on the other side equals 20. And just write them out like that. Another thing to be careful of is if you're changing the order of the variables. So you might have been given, this is a different question now, but if it had been 10y minus 2x equals 20, if you wanted to change that order, don't forget to take the negative with it. So it would be minus 2x plus 10y equals 20. Okay, it's not equal to, this is not the same as 2x minus 10y. You can try, just stick some numbers into that if you're not sure why, and look at what happens if you don't take the negative with it. Okay, so if you want to change the order, You've got to take that negative with the number. So it's minus 2x. This was positive 10, so it's plus 10y equals 20. Okay, so that's just rearranging. So the first thing to do is just tidy up those equations. So you've got the letters in the same order, so your unknown variables in the same order, top and bottom, and take your numbers across to the other side. Now, this one's a bit of a special case because this value on one side of the equation is 0. It might have been the second equation where it was 0. Whichever equation it is, that's the one we're going to use first. And it's often the case in statics problems. There'll be a heap of statics problems where one of them, they'll have two variables on one side and 0 on the other. You want to grab that one first. It's going to give you a bit of a shortcut, make life a bit easier. So what we're going to do is we're going to say we're taking 1. We'll just draw an arrow to show it's 1. Because I'm doing this for an example, I'm going to write out that equation again. But you don't really have to. You could jump straight to this next line. So that's going to be the same as 4x equals, need to add 3y to both sides to get the 3y on the other side. What I'm trying to do here is I'm trying to get x written in terms of y. So I want the x on its own. So x is equal to divide both sides by 4 3/4 y. And we'll call that equation 3. So far, so good. So we've used equation 1. We've written x in terms of y. What we're going to do now is we're going to take this and put it into equation 2. So we've got x here. I'm going to take that x and I'm going to replace it with 3/4 y. Why? Because then I'm going to have an equation, one equation with one variable, therefore we're going to be able to solve it. So you're trying to collapse these two equations down into one equation with one variable. So what we say is substitute. So we're going to substitute, just sub for short, sub 3 in 2. So we're taking this and we're putting it into this. So let's write that. Again, I'm going to write it out in full first, just so those that are looking at this in my uni, when I stick the working up there, they can see what happened. So might even draw a little line to explain what's going on. I'm going to stick that in there. Just going to move this up so it's easy for me to write. So then we're going to get 2 times, so x is the same as 3/4 y, so it's the same thing, 2 times 3/4 y plus 10y equals 20. Therefore, 3/4 times 2 is 3/2, because the 2's are going to cancel out. So that's going to end up with 3/2, which is the same as 1.5y. Stick it in the calculator if you're not sure. Plus 10y equals 20. Therefore, 11.5y equals 20. Therefore, y is equal to 20. Divide both sides by 11.5 to get rid of that times by 11.5. It's 20 over 11.5. Now, if this was maths, you try and keep that as a fraction so you avoid rounding errors. And so maybe you'd make it into a nice fraction, so you'd double top and bottom times a fraction. Same thing, top and bottom doesn't change the fraction. So you'd end up with 40 over 23, I think. Something like that. This is engineering, though. We're going to get lots of ugly numbers. We're not. So we've started with nice numbers 4 and 3, and an engineering equation that's going to be 7.345x plus 12.672y. You're not going to have tidy numbers to start with, so don't worry too much about rounding errors. Just try and keep enough significant figures. So we are going to do 20 divided by 11.5 equals 1.739. So that's going to be equal to 1.739. We're in maths land, so there's no units here. In engineering, that might be newtons or it might be millimeters, depends what problem you're solving. So now we've got y. So what we're going to do now, we'll call this 4, say. We're going to substitute 4 back into 3, because that'll let us figure out what x is. So we know x is 3/4 y. We figured out that from this equation. We now know y. Substitute that in here, we'll figure out what x is. So sub 4 in 3. Then we're going to get x is equal to 3/4y, which is going to be equal to 3/4 of 1.739, which is going to be equal to 3 divided by 4 times 1.739, 1.304. And we've now solved the problem. So we figured out x and we figured out y. What we're going to do is we're going to check it. And so we substituted this value back into here. This equation came from equation 1. So we don't want to use that for the check. We know it's going to work because that's how we figured it out. What we want to do is substitute it back into the other equation, equation 2, to check it. So let's do that. I might come back up to the top again. Check in equation 2. And these checks, I've said it a few times, I'll say it again, these checks are even more important than engineering. So in maths, the teacher will give you most of the marks if you got the answer right. If you're on site and you've got to do some calculations and you get it wrong, either it's going to cost a lot of money or someone might get hurt. So it's always worth checking your answers to make sure you got the right answer. It's also good for exams, then you get 100%. So what were we doing? Checking equation 2, and so we've got y. So equation 2, let's just write it out again. 2x plus 10y. Now when you're doing these kind of checks, what you usually do is you say the right hand side is equal to 2x plus 10y, which is going to be equal to 2. We'll put in what x is, times 1.304 plus 10. We'll put in what y is, down here, 1.739. times 1.7, it would help if I could write 1.739, which is equal to, so what should it be equal to? It should be equal to 20, hopefully. So let's see what happens. 2 times 1.304, oh, sorry, can't even see what I'm doing. 2, doesn't matter because it's wrong anyway. 2 times 1.304 plus 10 times 1.739 equals, near enough, 20, which is, oh, I did that a bit quickly. Let me make sure you can see what I'm on about. So we've got a bit of an error. Why is there an error there? Because we've rounded these values a little bit. So we've only had 4 significant figures. That 4th significant figure is a little bit out, but that's okay. It's near enough. So it's pretty much equal to 20, which is the left hand. Now, don't know my left from my right. So that's actually left hand side is equal to that. And this is equal to the right hand side. What the mathematicians say there is QED. So I've got their answer right, basically. Otherwise, just tick it to show that you can see that that's okay. So, okay. So therefore, we can just write our answer. So x equals 1.304 and y equals 1.739. Underline it. Easy problem. We'll go on to the next one.